How are you, my friends? This is lecture number 32 of the pre-calculus course, Gauss-Jordan Elimination Method. This lecture is related to lecture 31. 31 was Gaussian Elimination Method. Please, you can review it to see the difference. If you understand lecture 31, lecture 32 will be a lot easier. Now, at the end of this lecture 32, you can find some old exams questions for both lectures to practice. Now, the objectives here, we will look at the augmented matrix to stress the idea. What is augmented matrix? Now, we will look at the steps in Gauss-Jordan elimination method. Before, we had only Gaussian elimination method, which is almost the same, but we have little changes. Now we look at the end of that, we look at the inconsistent and dependent systems. Just quickly, I have mentioned this in lecture 31. If we have a 3x3 system here, 3 equations, 3 variables, if I need the augmented matrix in methods 4 and 5, I can write all the coefficients. See the first, they line up, all the coefficients of the x, all the coefficients of the y, all the coefficients of the z. And on this side here, after the line, I can write the constants. If I don't write the constants, this we will use in method number 6. We call this coefficient matrix. The name is different because they look also different. So method number 5 is Gauss-Jordan elimination method. The steps are easy. First, we write the augmented matrix. We have seen that many times in lecture 31. Now we use row operations to rewrite the augmented matrix to reduce row echelon form, which means we have to make ones in the main diagonal and zeros elsewhere, under and above the main diagonal. I will show you how now in the examples. And here, just to mention, there is no need for back substitution. So this method, Gauss-Jordan, is easier than Gaussian elimination method. Just to remind you of the aim here, this is Gauss-Jordan elimination method. Aim for 2x2, you have to make ones in the main diagonal here, 1, 1, zeros elsewhere, but we have to go by steps. Step 1, step 2, as we did step 3 also, we did in Gaussian method. Now we continue here in Gauss-Jordan to make this number here above the one here, this number 0, we make it 0. So this is step number 4 for 2x2. 3x3 is the same. I start here, 1, 2, 3. See these green colors, 1, 2, 3, 4, 5, 6. These are the Gaussian steps. I have to add 3 more. After this one here, in step number 6, I change this number here, step number 7, change it to 0. This number, change it to 0. Step number 8, step number 9, change this number to 0. Then I have ones on the main diagonal. You see that? Zeros elsewhere. Then this is x, and this is y, and this is z. Let's see the nice examples here. Look at this system. Use Gauss-Jordan elimination method. X over 6 plus y plus 5 over 12 is equal half. 2x over 7 minus y over 14 is equal minus half. Now we cannot start Gauss-Jordan elimination method directly because we have to work with the fractions, the LCD, we have to rearrange the system. So the method here is to multiply equation 1, as we see, by the LCD 12 and multiply equation 2 by the LCD 14 to make the system the simplest form. So let's multiply the first by 12. 12 divided by 6 is 2, that will be 2x. Here we cancel the 12, so we get y plus 5. 12 times half is 6. Second one, we multiply by 14. 14 divided by 7 is 2, times 2x is 4x, minus y is equal minus 7. We have to simplify a little more. 2x plus y, take 5 on the other side, becomes 1, and here 4x minus y is equal minus 7. So now this system is ready. We can write the augmented matrix of this system to solve it. So we write the augmented matrix 2, 4. We write the coefficients 1 minus 1, 1 minus 7. I need the first number to be 1. So divide row 1, or row 1, this is row 1 here, divided by 2. So I get here, divide this by 2, it will be 1, half, and half. And row 2, we leave it 4 minus 1 minus 7. Now I need to change this number 4 here to 0. So I have to multiply row 1, this is row 1 here, 1 half half, multiply by minus 4 and add to row 2. Okay, so multiply by minus 4 times the 1 is minus 4, plus the 4 is 0. Minus 4 times the half is minus 2. You add minus 1, you get minus 3. Minus 4 times the half is minus 2. You add to minus 7 is minus 9. See, to change one number here, you have to change all the numbers in that row. So here now we need the minus 3. This minus 3 down here, we needed 1. So to change this number minus 3 to 1, we divide by minus 3, all row 2, all of it. 0 divided by minus 3, minus 3 divided by minus 3, minus 9 divided by minus 3. So I get 0, 1, 3, which is nice. Now I need to change this half here, this half, to 0. So I multiply by minus half. Row 2, I add it to row 1. So minus half times 1 is minus half, add to half 0. Minus half times 3 is minus 3 over 2. You add to half, it will be minus 1 there. So now look at the system here. 1, 0, minus 1, 0, 1, 3. So directly we can say x will be minus 1, y will be 3, and the solution is minus 1 and 3. That's the point of the intersection. Let's take 3 by 3 now. Y plus 3 is equal minus z minus 4. X plus 1 equals minus 2y minus z. 10 equals 3x minus y minus 8. I advise you at this moment, stop the video please, or pause it, whatever. Try all this. I can tell you the steps now. Rearrange it first. Put all the x, they lie up together, the y's, the z, the constants. Write the augmented. Change the main diagonals to 1s and 0s elsewhere. You have to go by the steps and then check the solution. If you are ready, let's go. Let's rearrange it. See, in the first equation, we don't have any x, so I put here 0x plus 1y. See, there is 1y here. Take the minus z on the other side. Take 3 on the other side, becomes minus 7. That's equation 1. Now here we have x. Bring the y there, plus 2y. Bring the z, and take the 1 on the other side, becomes x plus 2y plus z is equal minus 1. The last one, I have 3x minus y minus 8. Bring the 10 there, minus 18. Now you can say 3x minus y, there is no z. Now you have to take it on the other side for sure. That will be 18. Now look at the system. Please make sure you understand exactly what happened here to make the system arranged. Now I write the augmented 0, 1, 3, 1, 2, minus 1, 1, 1, 0, minus 7, minus 1, 18. Now I start. This is 0. I cannot have 0 there. I should have 1. See, there's a 3 there in row 3. I don't take it. So there's 1 here. So I can interchange row 1, row 2 only. So 1, 2, 1 minus 1, 1, 2, 1 minus 1, and here 0, 1, 1 minus 7. So now this is 1, this is 0. I have to go directly to this 3 and change it to 0 there. So I have to multiply minus 3. Row 1, because that's 1 here, minus 3, the opposite. Add to row 3, but you have to change the whole row. So minus 3 times the 2 minus 6, and minus 1 is minus 7. Minus 3 times the 1 is minus 3, add to 0, minus 3. Minus 3 times the minus 1 is 3, add to 18 is 21. Now, this is 1, 0, 0. This is already 1 now, which is good. Now I have to change this number here, the minus 7, to 0. Let's continue, please. The opposite of minus 7 is 7. So I multiply 7 times row 2, and then I will add to row 3. So this becomes 0, 1, 1 minus 7, 0, 0 minus 4, 4 only, because 7 times the 1 minus 3 is 4. And 7 times minus 7 is minus 49, plus 21 is minus 28. Now we can continue. Here we need 1, see? So you divide by 4, divide by 4. So this is 0, 0, 1 minus 7. I found Z now. Now we continue to change this number here. See this one here in the middle, this one to 0, this one to 0, and then back this 2 to 0 also. So we have to continue now by Gauss-Jordan Elimination Method. So I change these two numbers into zeros. I put the steps here for you. You can check it, please. And then I need to change this 2. So I take row 2 now. See row 2, times minus 2, add to this. So I get 1, 1, 1, 0, 0, 0, 0, 0, 0. Everything zeros here except the main diagonal. So x will be 6, y will be 0, and z will be minus 7. This is the solution. Now let's see more. Find the value of k. This is a nice question, by the way. Find the value of k if the linear system here, we have a linear system with some fractions, and there is k there. It's mentioned in the question that the system is inconsistent. That means no solution. What is the value of k? So we can start normal. See, the system is arranged. Directly, I can write the augmented. So this is 2 and 6. K minus 7 over 3, 2k over 3, 4 on the other side, k minus 9. Now, this number is 2, yes, it should be 1, but I can leave it now for a minute and multiply directly by minus 3 to change this number to 0. Because when we say the system is inconsistent, that means there are some zeros in one row. Maybe all zeros, maybe zeros and a number. We have to check. So the important thing here, not this one, because I'm not finding the single solution. I can divide by 2 if you like. You can divide by 2 normal. But here directly, there is 6 here. So I multiply by minus 3 to make minus 6. And then I add to 6, it will be 0 there. Remember, minus 3 times this will be minus 3, k minus 7 over 3. You add to 2k plus 3. Please go slowly here to understand what I wrote here. Minus 3 times 4 minus 12. You add to this. So k minus 9 minus 12. Now remember, when we say inconsistent, the last row here, or any row, it must be 0, 0, not 0. Like 0, 0, 5, 0, 0, minus 6, 0, 0, 1, half, or 0, 0, 77. So we should have 0 and 0, not 0 there. So the important thing is I take all this, see this number here, the coefficient, all this, put it equal to 0 because this one is already 0. When I finish, I will discuss this because there is a k there. So let's continue, please. So to have inconsistent, see when you simplify here, you get minus k, make sure you get that one, minus k in the middle here, plus 21 over 3. Take all this should be 0. Now cross multiply, k will be 21. So to have the system inconsistent, k should be 21. But be careful. 21 is rejected. Why? Because if I take K21, I have to put also here K21. So if I put there 21, it will be 0, 0, 0, which is infinitely many solutions. So the final answer for this question, no value for K will make the system inconsistent. Now, if we look at example 6, we see that the system is already arranged, so we can directly use Gauss-Jordan elimination method by writing the augmented. We know how to write that, it's already there. And now I notice here there is one, the first element here, then I have to change it to 1. So I can take row 3 there, interchange row 3 and row 1. So 1, 1 minus 3, 1 becomes at the beginning here. And then 3 minus 2, 1 minus 7 will go down in row 3. Now, I have 1 there already. Now I use row 1, all row 1 here. This is all row 1 to change row 2 and row 3. So I will change this number here 2 to 0, and I have to change this number 3 to 0. And we did that many times. I will do it again here. Minus 2 times this, you add to 2. Minus 2 times the 1, you add to this, you get minus 1. Minus 2 times minus 3 is 6. Minus 4 is 2. Minus 2, that will be times 1. Minus 2, add to 0, minus 2. Same thing now for row 3. So I have 1, 0, 0. This should be now 1. So we can continue here to change this number in the middle here, minus 1 to 1. So we multiply row 2 by minus 1. So we get here 0, 1, minus 2, 2. Row 1, row 3 will stay the same. Now we need to change this minus 5 to 0. The opposite of minus 5 is 5. So I multiply all row 2 by 5. So I get here 0. 5 times minus 2 is minus 10. I add to 10, I get 0. Here I get also 0. 0 equals 0 is correct. So I can drop the last line. And then the system here is dependent. It has infinitely many solutions. So we can start here by saying, let z is equal to t, where t is any real number. So I can use row 2 here. So I can write y minus 2z is equal to 2. I put here z directly t, so y will be 2t plus 2. So I found z is there, y is there, I need x. Now I can use row 1, x plus y minus 3z is equal to 1. So I put in the y 2t plus t, I put in the z only t, and then I find x will be t minus 1. So this is the general solution. T minus 1, 2t plus 2, t, where t is any real number. Let's look at example 7. Solve this system here. We have 3 by 3, but it is not arranged. So please take a minute here. You can rearrange it and then write the augmented matrix. So this is the given here. Let's rearrange it. So I keep here x minus 3y. Z, take it on the other side, becomes 1z is equal to 5. This one is 3x, take it on the other side, 3x minus 8y plus 2z is equal to 12. And here I have 2x, 3y, bring it there, becomes minus 6y plus 2z is equal to minus 10. So the augmented matrix now will be 1, 3, 2, minus 3, minus 8, minus 6, 1, 2, 2, 5, 12, and minus 10. This one is already 1, so I have to change the 3 into 0. I have to change this 2 into 0. So I take row 1 and multiply it by minus 3, because this is a 3 there, so the opposite will be minus 3. Multiply by row 1 plus row 2, it will be 0, 1, minus 1, minus 3. Because minus 3 times minus 3 is 9, minus 8 is 1, minus 3 times 1 is minus 3, plus 2 is minus 1, minus 15 and 12 is minus 3. Down here I say multiply by minus 2. So this becomes 0, this becomes 0, this becomes 0, this becomes minus 20. So 0, 0, 0, 0x plus 0y plus 0z is equal minus 20. 0 cannot be minus 20, so the system is inconsistent and we have no solution. Now, this is the summary of all the special systems. Sometimes we have a single solution. You can see the examples 1a, 2, 3, and 4. You can see the system where it is inconsistent and there is no solution. You can see the examples 1b, 5, and 7. You can see where the system is dependent and it has infinitely many solutions, we say. So this is example 1c and 6. Just to remind you of the steps, usually we have to rearrange the system first, then we write augmented matrix, then we use Gaussian elimination or Gauss-Jordan. Gauss-Jordan is easier, I think. Then we write the solution. Now, these are some old exams questions for you to practice. You can solve this by Gauss-Jordan elimination method. Question number 2, also you can use Gauss-Jordan. This is a 3 by 3. You can try, if this linear system, this is 3 by 3, is dependent and it has infinitely many solutions, find the value of this k. Question number 4, we have this augmented matrix. Find the solution. This is really nice to try. Question number 5, we have 3 by 3. This is augmented matrix given. Find the value of m. We have here m squared. We have here down m. Find the value of the m if the system is inconsistent. Question number 6, we have 2 equations, 2 variables, x and y, but we have some radicals here, ugly numbers. If the augmented matrix of the linear system can be written as 1, 0, 3 square root of 10 over 4, 1, EF. Find 4 EF. So what do you have to do? This is already arranged. Write the augmented matrix, make some transformation until you get 1, 0, 1. Then for sure you will get here this number here, 3 square root of 10 divided by 4. Then take these numbers ENF and multiply them by 4. Now these are the answers for the 6 questions. For complete solution, please, you can see the video on Gaussian and Gauss-Jordan elimination methods, lectures 31 and 32, pre-calculus old exams questions. Please try these questions before you see the answers. Thank you for watching. If you like the video, you can subscribe and share it with your friends. Just to remind you, this is pre-calculus course, lecture number 32. I wish I can see you in another video with another topic. Thank you for listening.